Good day, everyone, and welcome to this Gradle webinar. I'm your host, Oliver White, and I'm excited to welcome our very special guests today, Martin Odersky, Hans Dockter, and Trisha Gee. They likely need no introduction, but I'll give one anyway. Martin is the creator of the Scala programming language, who continues to oversee the development of Scala as head of the programming group at EPFL and as academic director of the Scala Center. Hans is the creator of Gradle Build Tool and the founder and CEO of Gradle Inc., the company. And Trisha is a Java champion, author, and head of developer advocacy at Gradle, and will be leading the conversation today. And today we're asking the big question: what does it mean to be truly productive as a developer in the modern JVM ecosystem? We're currently dealing with an avalanche of AI-generated code, which is stressing our CI pipelines, making our code batches bigger, our builds slower, our test cycles longer and more difficult to verify, and our security and governance policies more susceptible to threats. So what does all this mean for developer productivity, build tooling, and language design? How do we maintain quality, readability, and speed in a world of auto-generated tests and AI-assisted pipelines? So get ready to hear ideas and predictions from these industry luminaries today. Lastly, this webinar is brought to you by the Scala Center at EPFL and Gradle's hundreds of happy Develocity customers, including Iterable, which is a Scala shop that provides an AI-driven marketing platform for folks who, well, don't know terribly much about marketing. They have remote and hybrid job openings in their engineering, product, and security teams, both in the US and Europe. So check them out at iterable.com/careers if you're interested. And super lastly, come visit Martin and members of the Gradle team at Scala Days, August 19th through 21st in beautiful Lausanne, Switzerland. All right, that's all from me. Let's hand it over to Trisha, Hans, and Martin. Welcome, everyone. It's so great to see you.
Thanks, Oliver. I guess I will kick off with some questions. And this is kind of weird because normally in a webinar, people are asking me questions. So now I get to ask everyone else questions, which is kind of cool. But feel free to also ask my own opinion because I'm definitely not afraid to share my opinion. The first question we wanted to cover, and I'm going to try not to do this in a very scripted way because really what we want is a nice conversation particularly between Martin and Hans. So we will probably go slightly off track from time to time. It's something interesting to follow up on. But the first thing I really want to cover is what are the backstories between Gradle and Scala? What are the original goal of creating these technologies? And how has that changed over the last decade or so? So I first want to ask Martin, what was the original backstory with Scala, and where did you come from when that was kind of created, and what's happened over this last however long it's been?
Oh, yeah. So Scala is now 20 years old, 21 years old, actually. It started as an experiment. I was traditionally in both object-oriented and functional language camps. Very few people did that at the time. They were quite separate at the time. And I never could quite understand why there was so much antagonism between the two. So I thought that they would actually be quite a nice complement. And I worked more theoretically on figuring out how to best combine that. And then when I was convinced that this could actually be made practical, I said, well, let's build basically a demonstrator that shows that we can find a practical language that combines functional and object-oriented programming. And that became Scala. So first it was basically to prove a point, but then we actually got users, first very few, and then around 2008, 2009, a lot more. So then it exploded, and then we sort of had to deal with our success and say, well, now we actually have a language that people are using, so we have to maintain it, and we have to develop it further. And that led to the creation of the company TypeSafe, which became Lightband. It's now Akka, and to the creation of the Scala Center at EPFL, and that's where we are today.
From my curious point of view, because I'm more of a Java person, why would you select the JVM as your sort of as your platform for Scala?
That came a couple of years before essentially the reason was that JVM was the first platform that had a garbage collector, which is something you absolutely need if you want to do a functional language, and that was essentially portable across many platforms. So it was very attractive to say, well, here we have a language that supports the basic needs for functional programming, and it runs everywhere. So it was a no-brainer to pick it, and that's what we did basically. Yeah.
I think that's really cool. I think it's nice that the JVM can support the functional and the object-oriented stuff. And I love the fact that the JVM can support all these different languages, and we don't have to compete with each other. It's all kind of,
That was a lot earlier. That was in 96 that we did that with a predecessor language called Pizza. We named it Pizza because, well, Java is a drink for programmers, so pizza is food for programmers. And that was with Phil Wadler, who's a sort of another well-known people in functional programming. And when I did Pizza, I also said, well, first I have to find out what this new language is. In 96, Java was brand new. So I think it was still in alpha at the time when we started using it. And so I wrote a Java compiler to find out what Java is. And that actually became the Java compiler a couple of years later, because Sun actually acquired the compiler. And so that's sort of how I became a Java expert, so to speak, as well.
So your idea is, I want to learn this language. Let's write a compiler for it. That's how I'm going to learn it. And it will be the compiler.
At the time it was, well, I didn't intend it to be the compiler, but it actually turned out that Sun's first compiler for Java had a lot of problems. So they were quite glad that they could ditch it and get another compiler for it.
So Hans, similar kind of question. Gradle came along, I think, a little bit later than the earlier versions of Scala, but still same kind of time scale in terms of like I believe you were looking for a better way of doing stuff again on the JVM. So what's the backstory with Gradle?
The backstory of Gradle, at the end of the day, I would say it's test-driven development, right? So I was an early adopter of that practice, and test-driven development without good automation, right? That doesn't go well together. So I grew frustrated with the options that were out there. And similar to what Martin said, I said, hey, I made the joke, when I'm grown up, I want to write my own build system. For Martin was, I want to write my own compiler. And so it started as a pure experiment, right? Gradle, I had time between jobs, right? And then it was like, hey, there was interest from day one. So that's how it started. 2008 was the first released 0.1. And then I would say how things have evolved from my perspective over time. The big focus, right, initially for me was automate. How do we make it easy to automate, right? The feedback cycle of developers. And now the focus has more shifted towards how do we optimize the automation, right? In terms of how do we make the feedback cycle fast? How do we make the signal reliable and trustworthy? So that's the evolution, I would say, from my kind of what I'm focusing on.
And what I'm really interested in around having you two folks here is that how did you, Martin, and you, Hans, end up collaborating? Because surely, like, Scala has SBT and Gradle is not SBT. So how did you folks end up sort of working together?
It was mostly by people who moved from essentially Mirko was a student in my group at EPFL, and he was then a TypeSafe employee, and then he went elsewhere. But at some point, he essentially ended up at Gradle as a what is it?
Engineering manager.
Yeah, right. And we kept in touch during all that time. And I also was quite involved with his previous company, which was Triple Quote, which essentially had a parallel Scala compiler that could speed up the builds. So basically, when he joined Gradle, he told me about what he did, and he also worked on SBT integration in Gradle. And essentially, that's how I got into closer touch. Of course, I knew what Gradle was before; it's well known. But it basically happened when Mirko joined you, I guess.
Yeah, and philosophically, Trish, so it's as I said, the focus for us and also for the company to a degree, right? We still. Of course, one big focus is Gradle build to improve the automation. But then our other big focus with the velocity, right, is optimize the automation, regardless whether it's automation done by Gradle build tool, by SBT, by Maven, by NPM. And in that world that we have evolved, right? For us, Scala was a very important community, right? And there was no longer any competition, if you like, right? From our automation optimization platform, if you like, the velocity, right? We support Gradle, we support Maven, we support SBT, as I said, right? So that was a very, very good fit, therefore, and that's where we started to talk about, hey, we want to provide a better automation experience, right, for the SBT and Scala community.
I have like 60 different directions I want to take this conversation in, and I never really know which one to go in. Given that we're talking about build tools and tool chain, I know we're going to talk about AI. I know we advertised that in the webinar, but we're in an interesting space right now. One of the things, Hans, you wanted to sort of talk to ask Martin about was, given that the tool chain, your build tools, the testing tools can sort of impact your whole experience with the language. Martin, is there anything that you would do differently with Scala the language, or influence differently with the Scala ecosystem now that you've got all this experience in the language design and understanding how developers use your language? Is there anything you do differently, I guess specifically around perhaps the tool chain or something?
Yeah, maybe. It's exactly what I wanted to ask. Maybe, let's say that you learned, oh my God, at enterprise scale, right, there are certain problems with scaling the toolchain, maybe because even of a language feature. I don't know if that is the case. So is there anything we would say, hey, that is how I would either invest more into a certain area, or I would even change something on the language or whatever, right, to kind of make it more toolchain friendly, especially when thinking about large organization that develop software at scale?
I'm not sure. So far, it seemed to be quite orthogonal one to the other. I also with the tool chain, I mean the most important part is that it's IDE friendly, and there I believe that there are no fundamental challenges to do that. The other thing is how to what degree can you parallelize the build, and can you parallelize the language? And there we have a little bit of an issue, but nothing that couldn't be solved on the tooling side. So I don't think we should make compromises on the language side for things that can be solved by just essentially good technology on the tooling side. And I think that so far has been keeping up, I would say. Of course, some of the things, let's say if a language is more explicit in all the types, so you have to write all the types out and things like that, then it's probably easier for the tool to analyze it and not rely on essentially inferring these types and things like that. On the other hand, inferring types is a solved issue. The compiler can do it. The tools can use the compiler to do it. So I don't see a big deal there.
Given that we're talking about tooling and effectiveness and productivity, I think it is a good time to move on to GenAI. Because obviously that's the big thing that everyone's talking about right now. GenAI is going to make developers more productive, by which I believe it means write more code, which may or may not be the same as being more productive. So the question is, what are your observations regarding the effect of GenAI on code base quality, security, and understandability? Which one of you would like to go first? Neither of you.
I would like to hear Martin's perspective first.
So I think right now all we see is fragments of fragmented observations in a world which moves incredibly fast. So basically whatever we see today, in 6 months, it might already be completely different. I have the impression that but I see it that our students use it everywhere. It doesn't necessarily do them a lot of good. I think that's actually problematic because they stop thinking about developing, and essentially it's just, they use the tool to spit out the code, but that's not a learning experience. But that's a very special situation at a university. Development, I think we will have the same issue that on the one hand, AI is incredibly useful for this sort of grunt work. So you want to just use a certain API to do something which is not very deep or anything, but you have to learn the API, and it's super. It takes a lot of time. So now you can just ask an LLM to do it for you, and it will typically do a credible job, and that's a big time saving. So I think this is great. So generally, I think that the sort of pedantic grunt work will be taken out of programming, and you need a lot more higher level skills to essentially interact with these LLMs. And that's a part of a thing that worries me, because to develop that skill, you sort of have to go through the lower levels and sort of understand what the thing is. So sort of you have to learn. You can use a calculator, but you need to start with addition and multiplication manually to get there. So I think for programming, it will be the same thing, that if you're good, if you're a senior and an expert, then you can use LLMs and they can make you more productive. But how do you get there? So that's a big question. And how does the industry get there?
So, yeah, and that's a question based to Trish and to Martin. So my hypothesis, and not as my, I think, is that in general, right, we have to assume that GenAI generated code is less understood by the developer, right, than when they write it from scratch. So, and that for me has a consequence to keep that, to basically keep this under control. The tests will become even more important in that world, right? Not just as a validation, also as a specification tool, and as a tool to understand what is the code supposed to do. So I had now a couple of conversations with engineering leaders at larger organizations, and they envision a future where they say the code that is generated by AI doesn't need to be comprehensible at all. It's a complete black box, and the only thing that matters is the test. I'm not sure about that, right? I fully agree with the shift in less comprehensibility on a generated code. The test becomes more important. But do we foresee a world, or do you foresee a world where we can live with completely incomprehensible code?
Yeah, well, I think that's going to be a big problem. And I mean, with this world, I agree, tests will become more important, but also essentially, how do you know you're complete with your tests if they're also AI generated? And second, if you find a problem, and you will find problems, of course, how do you debug them? I mean, the tests don't tell you how you debug it. So if you don't understand your code, how do you hope to be able to debug your code? Okay, I guess your hope is you ask the LLM to say, well, fix this bug, and maybe sometimes it would, but what if it goes wrong? What's your fallback? And then if you don't understand the code, you have no fallback. You can just essentially junk it and start from scratch. And yeah,
I mean, from my point of view, I'm a big fan of tests. I've always been a big fan of tests. And I in an ideal world, your automated tests do document not only does it work, but how it should work. But I do think writing tests is a skill, and we haven't really taught that skill traditionally that well in the industry. And I think that there's a tendency to want to get the LLMs to write the tests as well. And so we have generated code, generated tests, and no one knows what's going on. And I think we're not going to get much better tests until we start getting better at educating people in terms of what a test is, how it should be, what it should look like. And also get developers excited about writing tests, because culturally, developers are not super excited about writing tests.
Yeah, indeed. Yeah. And also, of course, tests and code have to share some data definitions, which is essentially the model of your business, things like that. So if you don't have a model of your business logic, then you don't know what to write tests against. And that model has to be formulated in some kind of programming language. So, and I think that is something that you definitely will have to understand and will have to validate that it meets your requirements.
And that's a good point. That could bring us to domain-driven design and the whole ideas behind that, and what that means in a GenAI-driven world. So one thing I'm curious about: so do you see with your students as they're entering the job market, right? That you read everywhere the entry-level positions are kind of getting cut because of GenAI. So what do you recommend to them as a skill set they should develop to deal with that?
Yeah, right now it's definitely, I think for EPFL students, they're still, even in bad times, they usually find jobs. It's just a question whether they have 10 jobs lined up or only 1 or 2. Yeah, I think the skills would have to be, well, essentially doing the scientific approach to software development. That means that if your system is something that somebody else generated, an LLM or maybe some other person team, then essentially you need to be able to figure out what it does You need to be able to understand it and be able to fix it if there's a bug. And I think the right way to do this is sort of the way you would approach it if you did an experiment in the natural sciences. So you have to formulate a precise hypothesis. You have to work on a setup that you can validate or disprove this hypothesis. And from that on, it's step by step. And I think these skills are something that we can teach, that they teach in physics. And I think we should teach it in computer science as well. And we should basically see these systems as systems that we study and we can subject to our experiments. I think that is sort of a meta skill that I believe our students will always need to be problem solvers. That's in the end what they get hired, what they get paid for, and that's what you need to be an effective problem solver.
Hans and I have spoken about this a few times actually, about how experimental thinking is going to be effective going forward, because tests are effectively a way of testing your hypothesis and stating that your experiment succeeded, really. And in terms of, certainly with AI, but even with software development in general, approaching it from an experimental point of view makes more sense. I think it's going to do this if I do that. Let's see if that works. And I feel like we should start measuring ourselves in that way, not measuring lines of code for productivity, but how many experiments did we run? How much did we learn from those experiments? Are we moving forwards? And then we don't have to think about traditional metrics of productivity like lines of code or Git commits or whatever.
Yeah. And I think it's also it will also influence, or programming languages have an influence here, because in order to essentially formulate an effective experiment, you need to keep the number of variables that you mutate low. And that brings you directly to essentially a more functional style of programming, because that keeps the number of variables that can change low, and therefore increases the predictability of your systems. So I think to be able to do that, we need to work on the architecture of systems to be more domain driven, of course, and also more functional in the end.
I think Hans was going to say something. Before we do, we have a poll to ask our participants if they've been using GenAI. I'm not sure if I'm supposed to launch it or if Oliver can do that. So he might launch that while we're talking, because I'm interested in the experiences that others have had around. Oh, there we go. It's been launched. I don't know. We'll let that run for half a minute or so. Right now, lots of people are saying they use GenAI in their daily work. I wanted to follow up on something you said around the experimental thinking and skills that students will have that will be effective for them in the future going forward. So I kind of want to ask both of you, given that the way we've traditionally measured effectiveness at programming might not be the right way going forward, like what are the sorts of skills that developers have that are going to continue to be relevant in the age of AI?
Yeah, I mean, I think what we said, right? For me, the let's say the beautiful promise of AI is rapid experimentation in a certain way, right? It gets a lot of boilerplate stuff that slows down my experimentation possibly out of the way, right? So that is for me the exciting part, right? And but I would only repeat what we said, but that skill set, the experimental skill set, right, and mindset, that's what you need to succeed in that world. And then, of course, my perspective is then what is completely answering your question, right? But what is the risk, right, for not really getting the benefits of the world, right? And that's where I found the last DORA report on GenAI super interesting, making in a way trivial but also profound statement, right? That when you increase your software developer productivity, it doesn't mean you increase your capability to deliver software, right? And that is where, for me, the pipeline becomes, and the toolchain becomes such a crucial role, right? When you dramatically can now increase your capability to experiment, right? You still need the feedback cycles, right? The build, the test. How can they scale, right, in that new world? And that's, for me, absolutely crucial, right? To enter this new age of rapid experimentation, right? Supported by AI.
So I'm going to share the results of the poll because it's quite interesting that 75% of the attendees here have used GenAI in their daily work. 15% no, 9% no, but planning to. Only 1% know, but not planning to. So that's really interesting. Like GenAI, I think, like IDEs, is a tool that's here to stay, that we're going to have to embrace to learn how to work with it, learn its pros and cons. I mean, I think Martin mentioned IDEs earlier on, and having worked for JetBrains, an IDE company, I heard a lot of times over the last 20, 25 years, like, we shouldn't need to use the IDE. We should know everything at a really low level. We need to understand everything at a low level, or we can't troubleshoot stuff. I think we've seen with IDEs, for example, it's helpful to know how things work. When I worked on Head First Java, Bert Bates, who's one of my co-authors, he said they always like to teach one level lower. So it's useful to understand one level lower so you can figure out what's going on up here. I feel like LLMs and GenAI and stuff are going to raise us to a slightly different level. We're still going to need to understand what code looks like, probably, but I think we are going to have different mental models around how we work with it and how we can be effective with it. Would you agree?
Yeah, definitely. I mean, the sort of grunt work to just take us back and convert to code is taken away from us. That will be solved. But then the question is, well, what about the higher level? What about the spec? So we need to come with some requirements, or probably we need to be a lot more precise, that in the end we have long living systems. So we need to sort of have an infrastructure to say, well, what are our key abstractions of our business? How do we formulate them? How do we keep them? What invariants do we want to maintain? These sort of things. So we need understanding on this level. And that requires certainly knowing the code underneath, but maybe not following it in detail, as long as we can assure that the code does what we require it to do with tests, or maybe in the future even proofs that it's also possible. So I saw some interesting development there.
I would like to just one question. No, we talked about that a couple of months ago, right? Your perspective on prompt-based development and the parallel to UML. I found it very interesting, to the unified modeling language, right? That you threw a parallel between the two.
Well, it's just that essentially both UML was incredibly hyped by industry, and in the end it didn't quite work out that way, I think. So there's always this dream to say, well, we basically people don't want to be tied to software engineers, software developers. They want to liberate themselves, so they dream of this world without code, basically, whether it's UML diagrams or prompts or things like that. And I believe prompts have a better chance than UML, because UML in the end was just pretty pictures. But there is this issue that in the end, you have to model what you want precisely, because you can't just, except if your task has been done 100 or 1,000 times before, and you just say, give me the average of what a CRUD website is, and I'm sure that very soon, if not today, we can crank one out. But most business needs are not like that. Most business needs are special. So we say we have our special thing, and it's unique, and it doesn't really exist 100 times everywhere in the industry. And then we need to be able to model precisely what we want, and that is code. That is a programming language. It's just a programming language on a higher level. But I think that's I see it much more like going from assembly to essentially low-level languages like C, to high-level languages like Java or Scala, to essentially the next level up, where we have some key abstractions and a lot of the low-level stuff that we need to essentially get something that's executable is almost abstracted away.
I wanted to follow up on something that Hans said earlier on about software delivery pipelines, and if we're able to generate more code, and we're able to run more experiments, and we want to run more tests. Yeah. I'm kind of interested in how GenAI is going to impact our continuous delivery pipelines, our build times, our test times. It feels like if we can generate more code and generate more tests, it's going to put a lot of strain on our continuous delivery pipelines.
Yeah, it's a huge risk, a lot of strain and a lot of cost, right? So, and we see that already out there. Organizations are nervous about the CI bill, right? They soon have to pay to AWS or GCP, right? And they say might increase by a factor of 10 or by 2 orders of magnitude, right? So that is and that would not be sustainable, right? So we need to find efficiency solutions for that, right? And it's insofar interesting, right? Because they're all making their 5-year plans. Everyone, for good reasons, is making a big bet on UI, also in terms of how many people they need to recruit or don't need to recruit, because everyone will become more productive. And I think if you don't get this under control, right, this bet is at risk, right? It's pretty obvious. I mean, the feedback cycle is the bread and butter, right, of experimentation, of software development. And that has to, and so that has to be improved 100%. And it's already not in a very good shape today, right? So that comes on top of that.
I want to ask a follow-up question, Hans. Given that we are in the build tool space, how do you see AI influencing Gradle's products in terms of Gradle build tool or Develocity? How do you think it's going to influence those products going forward?
Yeah, I think it's a good question. I think the tool chain, when you instrument a tool chain, right, you create so much valuable information, right, about everything that happens before the code is shipped, right? And starting, we talked about security, right? Provenance information that you want to make sure, right, that certain practices have been applied before you deploy that code related to the production process. Could be an old plugin of SBT that shouldn't be used before something is deployed, right? Use it as quality gate. But it's also super interesting to understand developer workflow, developer productivity, right? If you instrument that data, and then obviously, right, GenAI can provide a huge leverage of making sense of that data. So for us, right, the tool chain has been underserved, right? What we have seen in the world of production with application performance management has been a complete huge maturity jump from I have no idea what's going on there to now having a very good understanding what's going on there. And that is a similar thing we are now in the process of seeing happening to the toolchain, the same professionalization, right? The DevOps principles applied to there, and observability is key, and all the data, right, that we can harvest from there is a wonderful opportunity, right, for AI. In what is one of the biggest frustrations, right? Oh, my pull request build failed, right? Is it me? Is it my code, right? Is it the build system? Is it the CI infrastructure? And there are so many events that are happening at this large organization in parallel where you can reason so well with artificial intelligence, right, about what most likely the root cause is. I see huge opportunities there.
And my experience as well of working very large organizations is that, like you said, production code has come like a long way, observability, all the DevOps stuff around getting stuff into production. But there are still plenty of organizations which are running their builds on some not well looked after piece of hardware, or there's lots of silos between the different steps for what they call a pipeline, but there's manual operations. And it feels like that kind of thing is going to creak under the strain of having like a lot of code being generated by GenAI.
Yeah, I have, in that context, I have one question to Martin, right? You mentioned a couple of minutes ago the super interesting area of formal verification, right? I was always, my naive, until you told me about it, my understanding was always, right, like unless you had very trivial code, right, it's impossible to mathematically prove that this code is doing what it's supposed to do. But you said a lot has happened in that area that might provide some glimpse into the future. How can it be also used for let's say the non-academic world or the non-mathematics world? Maybe, yeah, I would be curious to learn more about that and to hear more about that.
Okay. Yeah, so I think the two developments. So one is if software development gets cheaper with LLMs, basically a lot of things gets automated, so costs go down. We probably some of that will translate into over a lower cost of software development, maybe eaten up tool chain, like you say. It could well be that the developers we economize, we pay now to Amazon or Google for the CI. But the other thing is that if there's real savings, we might as well raise the bar of quality. That means we might actually have a larger footprint of things where we say we have complete assurance that these things are solved. So that's it. That's the one thing to say, well, if costs are down, then there's a chance that quality might go up. The other thing is that LLMs are actually starting to work also in verification. So they're not, we can use them to write programs, but we can also use them to write proofs. So the gold standard, so to say, it would be to say, well, I go to ChatGPT or Cursor or any of the other ones, and I say, okay, give me a code. I have a very precise spec what I want. Give me the code for the spec and give me a proof that your code satisfies the spec. So why shouldn't I be able to ask the LLM? And if the LLM can come up with a proof, then basically I have the assurance. I don't even need tests. Of course, I need to have the spec. That's a question. But then the LLM could actually furnish the proof. And then if something changes, I ask it to redo the proof. That's a bit in the future, but I think we're getting there fairly fast because the improvements that we see for programs also we see in proofs in particular. We noted we gave a course on foundations of programming languages and verification this spring, and during the course we noted that the LLMs got a lot better suddenly. The language we were using was called Lean. That's essentially one of these prover languages, and suddenly in the middle of the course what we did, suddenly the LLM could do it by itself. Well, there, of course, in teaching, it's always you teach something which is very repetitive. That means there are textbooks out there, there are materials out there from which they can learn. So that doesn't mean it generalizes yet to domains which are new, but still, it was amazing to see that.
I have that experience. Sorry.
And so you mentioned Lean, right, which is heavily used now in mathematics to basically prove the whole mathematical universe as the vision, which is amazing. How do you see that play out, right, in the, let's say, fuzzy world of business and enterprises and with much less defined clear requirements?
Yeah, exactly. So right. So of course, a whole business would never be able to be even formulated to the level of precision that you need for these things. But I believe that a business is also made up from components that some of them need to be verified precisely. Let's say your networking stack, and you want to say that certain things are essentially free from threats to security or attacks or things like that. And others are essentially much more fluid and less critical for security. And then you come sort of to the question of systems to say, how do you build a system from high trust components and low trust components that you have overall a high trust in your system? And that our bet, that's sort of my current research area, is to say we can get that to some degree by investing heavily in capabilities as essentially a software concept to interact between trusted and untrusted components.
So from a toolchain perspective, how is it expensive? Is it to create those proofs and run those proofs when you change the code base, let's say a large code base?
The proofs are relatively big, but I think so the difficulty is coming up with the proofs. Proving is very hard. It's an order of magnitude harder than programming. I think typically it's the domain of PhD students. They do a big proof as basically the main accomplishment of their PhD. That's the current state. But I think we can democratize it, and with the help of LLMs, and also probably improving these sort of proving languages. Like I think Lean was definitely a step forward, and there will be others. I imagine maybe Lean will improve, maybe somebody else will take the lead. We don't know that yet. So finding a proof is hard. Verifying a proof is not very costly. It's a lot cheaper than running a lot of tests, because basically you just essentially have to tick off every proof step. The proof is basically a big graph of inference steps, and that's recorded somewhere, and you just have to tick them off. So that's very fast. But creating it in the first place is hard. And the thing we don't know yet much is, since software requirements change all the time, these proofs would have to change. And right now we don't have a lot of data. Until very recently, it was an unsolved problem, how we adapt those proofs to new requirements. We had to start from scratch each time. Now with LLMs, there's also hope that basically they can help, like changing a program. You say, here's a proof, here's a changed spec, so here's the failure of the previous proof with the spec, fix it. So that there is scope for definitely progress there.
I want to get a chance to get to a lot of the excellent questions we've got in the chat and the Q&A. So I've got one final question for Martin before we move on to the audience questions. And that question was, where is it? I've lost it. How is AI poised to influence the design of Scala as a language and its focus on software quality, scalability, and developer productivity?
I wish I knew that. That's an excellent question. So I believe the one thing that will be important is this capability. So maybe I can explain a little bit more. So the issue is if you have built a system from modules or components, and you have, let's say, a high trusted system that you need to maintain the integrity of the system, and it makes calls to another low trusted system, and it gets responses, but the high trusted system will validate the responses. But now they communicate. And how does the high trusted system prevent the low trusted system of an unauthorized API call? So the high trusted system says, well, we have an API, but since the API is out in the open, a low trusted component could get in there and just do something it's not supposed to do at this point in time and things like that. And I think the answer there is essentially we do that with capabilities to say, well, in order to call a critical call in your API, you need to present essentially a permission that you're allowed to do that. And if the high trusted system doesn't give these permissions to the low trust system component, then the low trust component won't come back and mess up the high trust component. So that's been known for a long time, that 50 years or more, but it's been sort of a bit on the margin because it's been just very tedious to implement. And I believe that is changing. It's changing on the language side because I think Scala has very nice abstractions to express these things. And also to say, well, if it's tedious, give it to an LLM. An LLM can do that. It is everybody, most people in security and operating systems agree it's the right way to build a system. And I think right now we have the opportunity to actually follow the ideal and put these things in place because the sort of the counter arguments. So for instance, in Java, there was this Java thing with the applets, the disaster and things like that. So if they had used capabilities, it wouldn't have been a problem. Capabilities are bulletproof in this thing, but they didn't do it because they said, well, no, it's just too tedious to pass around all these things explicitly. That's definitely true. So let's do stack inspection instead, where you essentially these applets would run up the stack and see whether there's something security relevant or not, and then refuse the applet and things like that. But all that is sort of, you just patch up a thing rather than looking at the root. So I think there's an opportunity there, and that will also flow in the design of Scala in the future. Otherwise, I'm not sure, but I'm really following it with a lot of interest.
So I do want to move on to the audience questions, but I want to give you two, Martin and Hans, a chance to have any final comments or questions or remarks before I move on to the audience questions. Anything?
Yeah, the only thing is also to answer your question from a gradability tool perspective, right? It might affect how we have to evolve our DSL, right? So a DSL, it's a Groovy based with that is dynamic. It's harder for an LLM to reason about, right? So, and then you might get better answers for different build system, right? For that reason. So that's definitely, so you have to think about how good is your interface, your main interface supported by LLMs, and might have to evolve that because in the competition of tool choices, that might play a more and more important role.
That's a really good point. And actually, so Oliver's going to come on and ask a bunch of questions, but I want to pick one of the questions out because it actually relates to that. So the question was, Java, TypeScript, Scala, it won't matter soon. All that matters is writing the correct prompts. Agree, disagree? And I feel that ties into your answer there. Like, if the LLM is writing the code, if GenAI is writing the code, it feels like the language doesn't matter, but that's not strictly true, is it?
Well, I mean, you could say even without LLMs, what does it matter? It's mostly a matter of tastes, whether you prefer TypeScript or Java or Scala. They're different things. But languages are in the end they're tools for thought. So essentially, a language is the way you formulate your requirements, your modeling, your executable code, these sort of things. So they have to follow your thought patterns. And I think that there's no difference whether you write them yourself or whether essentially you consume them from an LLM. It's still a language has to fit the way you prefer to think. So if you are more functional, then maybe you would prefer Scala over Java or TypeScript. If you are more in the JavaScript world, you would keep TypeScript. And if you're essentially used to Java and that's your the way you deal with these things, then you will do that. So I think there's no really, it doesn't necessarily change the distribution. There are these things that you say, well, yeah, but Python, the LLMs will surely be much better to generate Python than other languages because everything is trained in Python, for instance. But I think that's also probably transitory. I think that LLMs will become better very quickly, and that will include being able to generate a number of languages. They can do that already for natural languages. Why they should be able to do the same for programming languages.
Do you think it matters if the language is dynamic, static, strongly typed? Do you think any of that impacts anything?
Yeah, I do. I think that, and there we come to MCPs, Model Controller Protocol, that I think generally the more we can open our systems, build systems, and also essentially the internal compiler static analysis to LLMs, the better the feedback loop will be. Because in the end, for an LLM, you want it to come up with the correct code itself without a lot of manual intervention and things like that. And for that, it really needs to know the APIs in a deep level. So if the LLM can already figure out that something is definitely type correct, then it's and your type system is strong, then it has a much higher chance of being actually the correct thing, what you want. So I think it will favor strongly typed and precisely typed languages.
Oliver, do you want to ask some of the questions that came from the audience? Because I saw there was a whole bunch of stuff on the chat and on Q&A.
Yes, absolutely. And I'm ready to go. Here's a good one that I'd like to hear from all three of you about. Can we or should we assume that GenAI tools will always act ethically the way we expect and make humans accountable? What happens when code becomes incomprehensible? Who's actually accountable for these problems? And should engineers be accountable for the full set of behaviors expressed in incomprehensible code?
Yeah. There's more than one question there, right?
Yeah. So, I mean,
who gets fired?
Right.
Say it that way.
So the fact is, right, when you say strongly legal responsible, right, a code is a hypothesis, right? You cannot prove, unless you formal verification, that it's doing what it's supposed to do. So to say, hey, who is responsible, right? Is it the developer? That's a difficult proposition. But you make a very good point. If the first question, can we expect it to act always ethically? Absolutely not. Because it's part of the tool chain, right? And we just saw a couple of supply chain attacks, right, recently, where people manipulated test frameworks, right? So that it didn't change the source code, they changed the build and the test execution, right, to get a backdoor into the code, right? Similarly, it's for just a question of time, right, when we see that also with LLM. So no, we cannot expect that, and there is a huge compliance question here, and that goes back to one of our very first conversation, right? When the code is completely incomprehensible, right? How can you manage that? And at this point, I only can say you cannot manage that if the code is a complete black box, right? But ultimately, the organization is responsible for what they're shipping, 100%. Right. And so they still need to maintain and get the tools and have the tools to fix this when something happens.
Actually, as a follow-up to that question, in this case, how do we actually test for behavior that shouldn't be there? We mentioned earlier that having GenAI create our tests and our code for us is very problematic. Could you want somebody elaborate on that a little bit?
If no one else wants to, I would love to answer this.
Please do.
Yes. I mean, firstly, you shouldn't really be having you shouldn't have the system under test, or the thing that creates the system under test also creating the tests, because you need something from the outside kind of like providing some kind of verification. Maybe this will change in the future. But if the AI generates poor code, how do you know it's going to generate good tests? Like, there's absolutely no reason to assume that it's going to generate good tests. You also, one of the other things about generating tests specifically is that unless you have a good specification, like Martin was talking about, the AI is just testing what it wrote or what you wrote. So it can only test what's there. It can't test that it's doing what it was supposed to do. What was it supposed to do? Have you connected your AI to Jira to find out what the ticket was? Does the ticket fully specify everything? Is the AI going to go back to the business and say, what should it do when the network goes away? You can't generate those kinds of tests. You need a real person to go, wait a minute, what happens when we do this kind of thing? It may be that developers don't have to write all the tests, because I think GenAI is all right at coming up with like some basic stuff, particularly around the sort of 0-1 many case or the null, or it is quite good at going, did you know there's an exception thrown here? Perhaps we should test for that. But the testing bit, and I feel so strongly about this, the testing bit needs developer or human interaction to be like, what is it supposed to do? How do we write down what it's supposed to do? It could be a document, but I prefer an automatable specification like a test, and then have the developer write those things down, make sure that the tests that have been generated by the AI are correct-ish, and then when those tests pass, then you know that the code, whoever wrote it, is doing the right thing. And also you can start thinking about, what's missing. You can ask the AI to go, okay, look at the code you wrote and critique it and tell me what's missing. And you can use it as a partner. But it's super important that someone who knows what they're doing looks at the code, looks at the tests, looks at the business requirements, talks to human beings and says, what is supposed to be happening here?
Great. Thanks for that, Trisha. Sorry, go ahead, please.
Even that, you still won't be able to test that there's no backdoor, because the system can be very creative to create a backdoor. So for that, I think you need either a spec and a full proof, which is still very, very expensive to attain, or you need an architecture that essentially minimizes those risks of backdoors. And that's where we come to capabilities, basically.
Yeah, and I think you need automation around some of these security things and understanding. Like, it's so difficult. I used to write a lot about code reviews. It's so difficult for a human to look at code and go, oh, there's a security exploit. Like, we just don't think that way.
All right. Next up, I like this one. If saying, quote, please is now regarded as an unwanted expense with AI, and I presume what we're talking about here is if you're adding more characters to the communication, it's more of a throughput issue and higher load. So what are some languages or tools that might be more cost effective than others? So Martin, I'm specifically thinking of Scala as having fewer lines of code than many other languages. Is this something that at scale will become a cost issue for company adoption or other considerations?
That's a excellent question. So it's a difficult trade-off. So on the one hand, people say very explicit languages, like, for instance, Go, are good for LLMs because they make everything explicit, so the LLM can really work with that. So languages that have more implicit knowledge, like inferred types, or in Scala's case, implicit parameters, how does the LLM recover these things? And that might indeed be a problem. On the other hand, you have MCP, where you say, well, these things are trivially exposable through a compiler interface, but that, of course, will again increase the bandwidth. So I'm not sure what the trade-off here is, and whether the language itself even matters, or whether it's sort of the combo of essentially language plus the interface through MCP of the internal static analysis.
It feels like this cost question might be, maybe I'm misunderstanding it. It's implying that perhaps more letters is higher cost, but also, we know from writing code, like it does, the cost in understanding and troubleshooting, if we've got smaller variable names and shorter classes and regular expressions, the cost it gets paid somewhere else.
Right, but I guess in the token model, probably those things wouldn't matter whether the variable name is long or short. It probably comes down to the same thing, more or less. But the question is, for instance, whether how explicit am I? Do I write out? Do I use a fold or a map, or do I write out all my loops explicitly, which would be longer but more repetitive, so maybe easier to understand for both humans and LLMs? And I think we just don't know yet, also because it moves so fast.
All right, great. This one I'd like to direct towards Hans because, well, Hans, you've interviewed many people over the years for jobs. One question is, what would you advise junior developers or students entering the workforce to pay the most attention to?
I mean, we talked a little bit about that earlier in the interview. I really, for me, in a way, right, when I look about what attracted me to software, it was definitely very much the modeling aspect, right? And the experimentation mindset, right? Versus the pure adrenaline from algorithmic problem solving, let's say, right? And I think that is what we're going to see, right? That people that are more attractive, more capable in that area, right? And for them, AI is not a replacement, but a huge catalyst and accelerator for their skill set, right? That would be my abstract answer to that problem. And of course, I mean, the other thing is, be very proficient with AI and really, fully embrace it, right? As the future that is not going anywhere, right? That's of course the I think nowadays pretty obvious part, right?
But I think you still need to keep the basics. You need to know the basics, and the danger is that those basics can get lost by just essentially not thinking hard enough anymore about programs and delegating too much to the GenAI.
Yeah, 100%. And that is where the modeling, I think that is a thing where I probably would deserve a complete separate session, right? The whole modeling the domain, right? What does that mean in the age of GenAI? But I fully agree with you. And it brings us also back to one of the points you made, right? Where you are skeptical, right? That prompt-based development will be basically the only UI that you need to develop complex software, right? So you still need to have code thinking at the very least, right? Because it's still the best tool that we have for expressing our thoughts that are supposed to be, executed. Yeah.
Something else that's always valuable, regardless of technologies, is learning how to learn and embracing the fact that you have to learn. I mean, you mentioned it already about AI models changing halfway through a course or whatever. I see it with demos. When I'm giving a demo from one week to the next, it changes. AI has just accelerated this. This has always been true in technology. We've always had to learn the new language, the new framework, the new whatever. But AI just makes this so much. It accelerates it so much. We have to accept the fact that we don't know what we're talking about from one week to the next. We have to accept that new things are coming. We need to figure out how to add them to our toolbox and how to use them.
Well, with that, as long as my phone still lets me pay for things, I think we've got some time. Well, Martin, Hans, and Trisha, I want to say thank you for this excellent conversation and exchange. It was illuminating and fun, and I really hope we can do something like this again.
Yeah, it was great.
Okay.
Thank you so much, Martin, for coming. Thank Trisha as well.
Thank you, Martin and Hans. It was a good conversation.
It was indeed. Thank you both and the audience.
All right.
So our interaction from the audience is really good.
Yeah, it's been great. I'm going to save the chat so that everyone can review it later on. Well, folks, that brings us to the end of our session today. Thank you very much for tuning in and have a productive day.
Thanks.
Bye-bye.